Hi guys, thank you for watching my previous video. Today we are taking a look at trigonometry. Let's take a look at this question. Okay, we have a very typical question of trigonometry here. Okay, it says a man observes a building CD from the top of A, and we have all the parameters given as such in the diagram. AC is 104 meters, AD is 90 meters, and angle CAD is 61 degrees. So part A, we are asked to find the height of CD. If you're familiar with cosine rule, sine rule, and area rule and all, you should be able to identify that we should use cosine rule to find the height of CD. Therefore, we get CD squared equals to AC squared plus AD squared minus 2 times AC times AD times cosine 61 degree. So let's put in all the numbers. And after punching the calculator, you should get 99.2 meters. Okay, let's take a look at part B. We are asked to find the length of BD. There are a few ways to solve this question, but let's take a look at the equation I formed first. In fact, I'm using sine rule here. First, I will find what is the angle of ACD, and then later on I will make use of this angle to find the equivalent distance of BD. So by rearranging this equation, I will get sine angle ACD equals to 90 times sine 61 degrees over 99.2. So I am shading the angle ACD we are trying to find. Therefore, after punching the calculator, you should get angle ACD equals to 52.51 degrees. After finding this angle, and AE has the equivalent distance of BD. So what we need to do now, in fact, we can just simply find out what's the distance of AE in the triangle of ACE. Therefore, sine angle ACE equals to AE over AC. After putting in all the available data and punching the calculator, AE is equals to 104 times sine 52.51 degree, and we get 82.5 meters for AE. So we have found the length of BD as well, because AE is equal to BD. Okay, now let's take a look at question C, angle of elevation of C from A. Okay, let me copy and paste the question over. So part C, we need to find the angle of elevation of C from A. Okay. Let's copy this diagram over so that we don't have to switch back and forth. So over here, you can clearly see that C is actually above A. Therefore, the angle of elevation of C from A is highlighted in the diagram in red. So, how do we find this angle? In fact, we can find this angle by angle sum of triangle, because we have found angle ACD just now in part B. Therefore, part C, angle CAD, which is also the angle of elevation of C from A, equals to 180 minus 90 and minus the angle ACD, which is 52.51 degree we found in part B. Therefore, let's punch the calculator and we should get 37.5 degree. And please state your reason. The reason is angle sum of triangle here. We have finished for part C. Now let's go on to part D. Part D, we are asked to find the angle of depression of D from A. D is clearly below A. Therefore, I will highlight the angle we need to find in the diagram in blue. Therefore, this angle of depression of D from A, angle DAE, equals to 61 degree minus 37.5 degree, which is 23 degree. So now let's take a look at another example. So before we need to find TF for part A, let's extract this triangle out. So we have a right angle triangle TFA. Angle TAF is 20 degree and AF equals to 180 meters. Therefore, TF can be found by tangent 20 degree equals to TF over AF, because of tangent angle equals to O over A, opposite over adjacent. Therefore, TF equals to 65.5 meters to 3 significant figures. Okay, next, we are asked to find the distance of BF. So similarly, let's extract this triangle out. So we have a right angle triangle TFB with angle TBF equals to 25 degree. Therefore, to find BF, which is the adjacent, we can use Tokaso again. So over here we use tangent 25 degree equals to TF over BF, opposite over adjacent. Therefore, BF equals to 140 meters to 3 significant figures. Okay, now we have come to part C to find the possible distance of AB. Okay, this question is slightly tricky because it's not as easy as you think or as direct as you think. Let's draw this triangle out. So one of the scenarios can be AFB prime. Another scenario can be AFB prime prime. Because the question never says what is the distance of AB, and we cannot just assume that. Therefore, I have already draw the diagram and label the data we are given. Therefore, in triangle ABF, we can use sine rule to find our angle ABF. In this case, AB prime F or AB prime prime F. Therefore, AF over sine angle ABF equals to BF over sine angle FAB. The answer should be angle ABF equals to 59 degree or 59.2 degree or 120.98 degree. So we have two possible answers here. The reason being, sine angle ABF is equals to 180, which is our AF, times sine 42 degree. 42 degrees is our angle FAB, over 140.49 degree, which is our BF. We found in part B. Let me beautify my answer a bit. It's still not good enough. Okay, let me do it again. So after punching the calculator, you should get 59.02 degree or 120.98 degree for angle ABF. So with these answers, we can actually further analyze this question. Okay, let me copy this answer over to the next slide. You see the convenience of software or technology here. We can simply copy and paste whatever we want and delete whatever we don't want. You cannot do it with a pen and pencil. Okay, give me some time to move the thing to the correct position. Okay, case 1. Case 1 is when angle ABF equals to 59.02 degree. And I hope you still remember the diagram. If you don't, never mind, I'm going to copy this diagram over. Once again, you see the convenience of technology here. Let me move this diagram to a good position. Okay, so we can start now. So obviously, angle ABF equals to 59.2 degree. This refers to angle AB prime prime F. So once again, by sine rule, AB prime prime over sine AF B prime prime equals to 180, which is our AF, over sine angle AB prime prime F. Therefore, angle AFB prime prime equals to 180 minus 42 degree minus 59.02 degree. we get 78.98 degree angle sum of triangle. Therefore, AB prime is equals to 206.1 meter. So now let's take a look at case 2. So case 2 is when our angle ABF equals to 120.78 degree, and this refers to angle AB prime F. Using sine rule again, AB prime over sine angle AFB prime equals to 180, which is our AF, sine angle ABF, which is AB prime F. And once again, we need to find angle AFB prime, which is 180 minus 42 minus 120.98. So we get angle AFB prime equals to, let's punch the calculator, we get 17.02 degree. Therefore, we can sub in this value into the above sine rule equation. And therefore, AB prime equals to 61.5 meter. So we have found AB prime 206.1 meter and AB prime 61.5 meter. So now it's easy for us to find the area of triangle AFB in two scenarios, because we have already found out AB prime and AB prime prime. Okay, let's take a look at case 1 and find the area of AFB prime. So we can use area rule, half times AB times AF times sine angle. Therefore, we sub in all. The area we get is 3,700 meters square. For case 2, once again we can use area rule, half times AB prime prime times AF times sine angle. Let's sub in all values. We get 12,400 meters square. Thank you for watching my video. See you again. Bye.